and talk about 534. 534 says solving quadratics, but we're using factoring. Well, solving quadratics using factoring. Why are we doing it this? Well, we just got done testing over factoring. Factoring should be fresh in your head, and you should be really good at factoring at this point. So the first method that we chose to teach you to solve a quadratic was factoring. Okay? A couple rules. Step number 1 is set it equal to 0. Step number 2 is combine like terms. You may not know what these mean. I'll explain in a second. And then step number 3 is make sure that it's in standard form. What does that mean? That means ax squared plus bx plus c is equal to 0. So it should be equal to 0. We need to combine any like terms and make sure that it's in standard form. Step number 4 is factor. Sorry, not factoring. Factor. Step 5, break it up and set equal to 0. Step number 6 is to solve. Step number 7 is to check. I didn't do these first block. I didn't write them down like that, but I think it'll be beneficial for the video and for y'all if you write them down. We have graph quadratics, we have factored quadratics, and now we are solving quadratics. We want to know where the graph crosses the x-axis with certainty. Before we can do all this, we got to do a little prep work. So I'll give you a chance to copy all that down, and then we'll do some prep work. All right, everybody good? You still writing? Marley, are you good? Okay, everybody got a copy? All right, here we go. 3x minus 4. Well, we'll just say x minus 4 is equal to 0. What does x equal? Everybody in here should be able to do that in your head. What does x equal? We move the 4 over and we get 4. How about 2x minus 4 is equal to 0? What does x equal now? If you notice, it's the opposite of this number divided by this number. So how about this one? 7x plus 9. What does x equal? The opposite of this number divided by this number. Right? So that'd be what? What does x equal? Well, if you did it the long way, you get 7x is equal to negative 9. Divide by 7, divide by 7. X equals negative 9 over 7. But you can look at it. Opposite of this number over this number. Okay, so rapid fire. Tell me what these equal. Tell me what x equals. This is just review. What does x equal? Negative 1. How about now?
Negative 1/3.
Negative 1/3. What does x equal now?
Negative.
Opposite over. Negative 2. What does x equal now? I think you got this, but I'm going to do one more. 7 over 5. Anybody having trouble with that? That's just basic linear, solving a linear equation. All right. Conceptually, I want you to think about this. AB is equal to 0. Write it down. AB is equal to 0. What must be true if AB is equal to 0? Don't yell it out. I want you to think about it. If you take A and you multiply it times B, and you get 0, what must be true? Somebody raise your hand and thinks they know the answer. Swavey?
One of them has to be 0.
Outstanding. Write that down. He's exactly right. One of them must be 0. Not both of them. Right? They both could be 0, but it doesn't have to be. One of them must be equal to 0. Do you see right here where it says break it up and set it equal to 0? What that's saying is if we have two things and they are multiplied to give me 0, then either A equals 0 or B equals 0. One of them must be equal to 0. Okay, one of them must be equal to 0. Alright, so what does that mean for quadratics? Everybody got this? Alright, so what if it looks like this? X plus 2 and x minus 3 is equal to 0. If I take two things and I multiply them and they equal 0, what must be true, Swaby? Say it again, exactly like you said it earlier.
One of them has to equal 0.
One of them has to equal 0. Do you know which one? Does anybody in here know which one of those two factors equals 0?
Doesn't matter.
Doesn't matter. We set both of them equal to 0. X plus 2 is equal to 0, and x minus 3 is equal to 0. We break it up and set it equal to 0. Alright, what's step number 6 say? Can you solve? We just practiced solving. You should be able to solve it in your head. Andrew Williamson, tell me what the answer is. And what does x equal?
-2.
And?
3.
Positive 3. Notice I wrote it without parentheses. Write that on your paper. No parentheses. If you put it in parentheses, it looks like a what? It looks like an ordered pair. Outstanding answer. It looks like a coordinate. So don't put it in parentheses. If you're dying to put it in something, you can put it in the curly brackets. Right? You can put it in the curly brackets, but do not put it in parentheses. Why? Because it could be confused with a coordinate pair. Alright, so you ready for another one? Two things multiply together equals 0. One of them must be 0. Break it up and solve. You can do this in your head, guys. You don't have to write it all down. How about this one? 3x minus 4 and 2x plus 6. What does x equal? What must x equal? X does not equal 0.
4 over 3.
4 over 3. Very good. And
-3.
-3. Anybody not see how we got that? We solved this one, and we solved this one. How do we solve? The cheater way? Opposite over. Opposite over. Anybody not see how she got those two answers? Raise your hand now. Yes?
Would that 4 be negative?
Because we do the opposite. See, if we went and we took the time and we did this, we would add it. So it would be positive. To move it to the other side, we got to add it. Okay, questions? You want to do another one?
Yes.
You got two things. You multiplied them and you got 0. What must be true? One of them is equal to 0. I don't know which one. So you break it up and set it equal to 0. You say this value is equal to 0. You say that value, x minus 6, is equal to 0. X equals 0. I don't have to do anything. Right? If I plug in 0, then it works. If right here, what do? I add 6 to both sides and x equals 6. So the answer is 0 and 6. You ought to be able to look at it and say 0 and 6. Questions? Any questions? I worked that one out because it was a little different. What is step number 7? How do we know that we got the right answer?
Plug it in.
We take 0 and we plug it in. There and there. 0 times -6 is 0. How about 6? 6 times 0 is 0. They work. Write it down. To check, you do just what Justin said. You plug it in. Is that nice? That you have a built-in way of checking your answers? Sure it is. That makes things a lot easier. All right, let's try another. Then we're going to move on to something else. ate up hard. Got some fractions in there, no big deal. Raise your hand if you think you know the answer. Only one person? Nice. 2, 3, come on now. All right, 4, 5, 6. Brown, what do you got?
4.
X equals 4, good, and?
Half for 7.
It would be negative that, opposite of that, over that. So it'd be negative 4 over 8, which reduces to what? Negative 1/2. Okay? Write in your notes. Always reduce your fractions. And then also, I don't want any decimals. I don't want negative 0.5. No decimals. The nice thing about algebra is you can leave answers as improper fractions. 4 over 3 is perfectly acceptable. Okay? Improper fractions are okay in algebra. All right, so let's do some more practice. Here we go. Tell me what the roots are. Don't yell it out. Think about it. Tell me what the roots are. What does it say? Solve the equation by factoring. I say roots. You might say zeros. It might say intercepts. It might say solutions. You could say any of those 4 things over there. What are the answers?
3 and negative 5/4.
3 and negative 5/4. Outstanding. All right, how about this one? Don't yell it out. Think about it. What are the 2 solutions?
1 and negative 5.
Oh, not 1.
Negative 1.
Negative 1 and what?
Negative 5.
Negative 5 over 3. Okay. How would you know, Durden, that those are the 2 answers? How could you know?
Or you had like plug it back in?
That's right. You would plug it back in to check. Negative 1 right here makes this 0. 0 times blah, blah, blah is 0. I don't care what the other one is. Anything times 0 is 0. If I take negative 5/3 and I put it right there, this becomes 0. Okay, so it checks. All right, try this one. Easy, yell it out.
4 and negative 1.
4 and negative 1. Oh, how about that one? What about this 4 out here? What does it do to the problem?
But you have to distribute it.
It's already factored. You want it fully factored. Does the 4 change anything? No, it doesn't. Because it's not a variable, it doesn't change anything. Right? You would do 2/3 and negative 1. Those are your 2 roots. If there happens to be a variable out here, like a b or an a or an x, then you get 0. But the 4 does not change anything. Watch, I can't write on the board here, but if I were to divide this by 4 and divide this by 4, it would go away. 0 divided by 4 is just 0. So the 4 basically disappears. It vanishes. All right, how about this one? What are the 2 roots?
3 and 5.
3 and 5 are the 2 roots. Anybody not getting this? Anybody? All right, how about this one? 4 and 1. How about this one? Nope, not yet. How about that one? 4 and what? Negative 1/5. Does the 2 do anything to the 2 zeros? No, it does not. Okay? All right. A little practice. All right. Hit the lights, Brown. All right. So now, let's put it all together. I'll use this example that we have right here. X squared minus 3x minus 10. Right? They're not going to give it to you already factored. They're going to make you do the work. What's step 1 up there? What is step 1? Set it equal to 0. Well, this first example is easy. It's already equal to 0. What's step 2? Combine like terms. Well, there aren't any like terms. What's step 3? Put it in standard form. Guys, those have to be automatic. You have to be thinking, set it equal to 0, combine like terms, get all of your like terms together and put it in standard form. You will begin to do that almost automatically. You won't even think about it. Okay? Step 4. What is step 4? Factor. We just got done factoring for 3 weeks. Everybody in here should be able to factor that trinomial almost instantly. What are the factors of negative 10 that add up to negative 3?
X minus 5.
X minus 5 and x what?
Plus 2.
Plus 2. Don't just guess. You need to check. Right? What's negative 5 and positive 2 multiplied? Negative 10. What's negative 5 plus plus 2? Negative 3. So it checks. Right? You're doing the little diamond problem right here. Negative 10, negative 3. You're doing negative 5 and positive 2. You're doing that in your head. Almost. Once you get to this, then we do number 5. Break it up, set it equal to 0, solve, and check. What are my two answers?
5 and negative
5 and what?
Negative 2.
Negative 2. All right, who could tell me step by step what we would type into the graphing calculator in order to check it? Right? These are easy to check, and you can do them by hand. But let's say it was a fraction, and you wanted to do it step by step on the graphing calculator. How would you check this problem? Who can tell me? Turner? Tell me what to type in. If I'm going to take negative 5 and I'm going to plug it in, tell me what to type in.
I'm not sure. Sorry.
Parentheses, 5, parentheses,
Squared.
squared. Then what would I type in?
Negative 3 times the negative 2.
Parentheses, always put what you're plugging in parentheses, 5, and then what?
Minus 2.
Minus 10. What should that equal when I hit enter on my graphing calculator? What should that equal?
0.
If I did it correctly, then I get 0. Those of you with the calculator, practice. And try that. Practice. Type it in. You will know without a doubt that you got the correct answer. Why? Because you plugged it in. Because you're plugging and chugging on your calculator and you're able to check your answer. Questions? Durden. Look, I don't need a calculator. What's 5 squared? 25. What's negative 3 times 5? Negative 15 minus 10. 25 minus 15 minus 10 is 0. It checks. You don't need a graphing calculator to tell you that. Okay? Questions? What would I do with negative 2 to check? What would I change about this? I put negative 2 right here, and I put negative 2 right here. Right? And I plug it in negative 2. Negative 2 squared is 4. Negative 3 and negative 2 is positive 6 minus 10. Up, it equals 0. So it checks. That's not a mistake. That's not magic. Right? If you've solved it correctly, your roots will work in the original equation. Write that down. If you've solved it correctly, your roots or your zeros will work in the original equation. All right, so let's go back through our steps. Step 1, set it equal to 0. Done. Step 2, combine like terms. Done. This was an easy problem. Step 3, put it in standard form. That has to be automatic. Well, it's already in standard form. Piece of cake. Step 4, factor. Y'all have to be gurus at factoring. Step 4, break it up, set it equal to 0. You can do that in your head probably. Step 6, solve. And then last but not least, check it. Okay, you ready to do some examples? All right, let's go right here. And let's do some more examples. All right, try that one. All right, what do you think the answers are?
Negative 3 and 4.
All right, does order matter? If up here, if I had said 4 and negative 3, opposite of what she said, does that matter? No, that doesn't matter. Order doesn't matter on these. They're in either order. Let's go back and talk about it. What does that mean that the graph of this does? If I were to pull up Desmos, right? If I pull up Desmos and type it in, here we go. Apps. Come on, be in my apps. Be in my apps. Desmos, there it is. All right, help me out. Let's see if I remember the equation. Here we go. x squared, right there, minus x minus 12. Was that right? Is that what the equation was? Oh, look at there. Where are my roots? At 4 and at what? Negative 3. That's not a mistake. Right? Before solving, before you knew how to solve, we had to guess at those 2 points. Remember, I just said draw your parabola and kind of guess where they are. Now we're able to find them. Right? Without any technology, without any software, y'all are able to find the roots definitively and say that the graph crosses at negative 3 and at positive 4. Right? You're able to find the vertex by doing negative b over 2a. Okay? Questions? Any questions? All right, that was good. All right, so let's do another. What's different about this one?
It has a negative.
It doesn't equal 0. That's right. So in order to get it to be equal to 0, what are we going to have to do?
Cancel it out somehow.
How do we get the negative 2 to move to the other side? Come on, guys. Y'all know how to do that. You do the opposite, which is what? Plus 2. Turns that 23 into a what? 25. Do this one now at your desk. Definitely going to have to cut this out. The video will be forever long. Are you ready for me to work it out? You need another second. Did this add a whole bunch of complexity to the problem? Not really, right? All you got to do is just add the 2 over. Right? X squared plus 10x plus 23 is equal to negative 2. I add 2 to both sides and that makes this a 25. Over here I now have a big fat 0. Okay? What are the factors of 25 that add up to 10? X plus 5 and x plus 5. These equal 0. So I get x equals negative 5. I get it twice, right? Negative 5 and negative 5, but I only have to write it one time. You can write it twice. I wouldn't mark it wrong. Let's see how many times they wrote it. How many times you think they wrote it? Once or twice? Once. I only wrote it once because it's repetitive to say the same number twice. What does the graph look like? Somebody just make my day and tell me what that graph looks like.
The vertex is at negative 5, 0.
Outstanding answer. Keep going. 1, 2, 3, 4, 5.
Oh, and it, one second.
That's okay. That's okay.
And it points up.
It opens up. Outstanding. What else do we know about it? There's one more thing that we know about it. That you know about it. It just, oh, if you know this, you get a gold star from the day. Say again? Not 23. You're so close. It's 25, right? And we have to go equal to 0 is 25. Outstanding, guys. We're really making connections when we understand that, right? That we understand that there's one 0, and it happens to be the vertex, right? It opens up because A is positive. That the y-intercept's 25, that means that it goes all the way up to 25 in just 5 horizontal changes all the way up at 25. Right? We can find the mirror point over there on the other side. That's true connections being built and understanding what's going on. That you understand graphing quadratics. You understand factoring quadratics. And now you understand how to solve. Okay? Are there any other